All right, so we're going to continue talking about exponents today. And these first few problems are, in my opinion, they're very challenging problems. And then the last part is a little bit less of a challenge, but the the overall main idea of this is just to be able to take an exponent base and change the form of it um, as either another exponent or a fractional exponent. And I'll show you what I mean before we even go over these these examples. So we if we have the number if we have the number six, um, excuse me, if we have the number 36, we could represent 36 as 6 squared. So that's just one way that we can rewrite these bases as exponents. Sometimes we write them as fractional exponents as well, and we're going to look at an example of how to do that. Um, Actually, with our second example for today. So here's the first one we're going to look at, and this is a very unique problem. When we get to the last problems on this, the last problems are a little more common. This is a very unique problem. It says, find the value of a when we rewrite this expression as a times 4 to the x. Now, I think this is a very challenging problem, but our overall strategy is we're going to make this into two pieces and then factor it so that we just have something times 4 to the x left over, and then we're going to figure out what a is. So let's write out this expression here. This is 4 to the x plus 3 minus 4 to the x. And this just equals, we're going to split this apart. This is now 4 to the x times 4 cubed, and then minus that 4 to the x still. So all we've done is separated that into two different pieces there. Okay, so now what we're going to do is just figure out what 4 cubed is. That's 64. So we have 4 to the x times 64 minus 4 to the x. Okay. So we can't just say 4 to the x minus 4 to the x is 0 because of our order of operations. So just be mindful of that part. Next, we're going to factor out a 4 to the x. So our greatest, or if we factor out, let's see here. Yes. Um, yeah, if we factor out a 4 to the x, that's kind of like saying these two are one item and then this is one term. So if we factor out a 4 to the x, that's 4 to the x times 64. That still makes that part a true statement. And then now if we factor out a 4 to the x from here, we're just left with minus 1. So this equals 4 to the x times 63. And so the answer that it's looking for here is just that a equals 63. That's all this problem is asking us to do. So these are very unique problems. Let's see if maybe we can do one more of these. Um, so this next one looks like maybe it's not quite as challenging as the other ones, or as the last one we just did, excuse me. So it says, what's the value of a when we rewrite this? Um, so when we rewrite 29 to the x over 2 as a to the x, um, basically what we want is we just want to have an x um, by itself. So let me see here. We're going to rewrite 29 to the x over 2, we're going to rewrite that like this: 29 to the 1/2 to the x. So that's power of a power rule. So these are still the same statement here, but now we have something to the power of x. And really, we just wanted to figure out what that something is when we change it to a power of x. So now that's what that's what our A is going to be. That's the something that we're looking for. So our answer is going to be C for this one. Okay, let's look at another one of these. These are, in my opinion, these are very tough questions. Um, let's look at another one of these. So this one's a fractional, or probably we're going to use the quotient rule for this, but take a moment to look at this. It says, what is the expression for f of x when we rewrite it, when we rewrite 5 to the 4x plus 7 over 125 to the x as 5 to the f of x? Okay, this one is very difficult, I think. We've got to change this in terms of 5. So we'll start with the denominator, and we'll start with rewriting the denominator in terms of 5. So 125 is 5 cubed. So negative 4x plus 7 over 5 cubed, and that's to the power of x also. Okay, so now we have that part. Now we're just going to use um, our power rule, and this is just the same numerator, and that's 5 to the 3x. I think the toughest part about this question is figuring out what's the question really asking us to solve for here. And what it's asking us to do is, let's rewrite it in terms of 5 to the power of something. It's just kind of phrased differently. That's why I said it's an extremely challenging question, because of the way that they phrase it. It says, this is what f of x, and it says, what's the expression for f of x when we rewrite this as 5 to the f of x? Uh, so we'll keep going here. We basically just want to figure out what is the exponent part of when we write this in terms of 5 to the power of something. That's what the question's asking us to do. So we're going to use our same rules from before. We're going to bring this over the line, change the sign. So that's 5 to the negative 4x plus 7. And then we're going to minus 3x. And that's all over 1. Now this is 5 to the negative 7x plus 7. Okay. And then the question's just asking us, what is the f of x part? What's the exponent part that we got from this? So we're just writing that in our answer. And that's it. That's our answer, negative 7x plus 7. So just the way that these are worded, I think, can be a bit challenging. Let's look at another one of these. It's a little bit different. It's now saying it's going to give us some options. It's going to say which of these are equivalent, which of these are not equivalent. And I think the best way to solve these is to try to expand it as best as you can. At first glance, you might be thinking, well, none of these. Um, I think we can cross out this and this, because when we do the the product rule, this ends up becoming 5 to the 25m squared plus 25m, because we're just adding the exponents. We have the same base and we're multiplying. So when we look at it like this, we can now say for certain It is definitely not that, and definitely not that. But we also have to make some considerations for this 25 here. We can change this 5 to a 25, and we do that by writing it as 25 to the 1/2. That's equal to 5 because 25 to the 1/2 is equal to the square root of 25, which equals 5. So now that's 5. Our exponent never changed. It's just going to stay the same. And now we can apply the power rule, and we're just going to multiply these both by 1/2. So we get 25 to the 12.5 m squared plus 12.5 m. And that's all we can do for this problem. It does not equal 25 m squared plus 5m, so that one's not equivalent. So none of these actually end up being equivalent. Let's try one more of these, and maybe we'll get one that is equivalent, so that might help so we can see an example that is equivalent. So it says determine which expression is equivalent to 6t squared minus 2t. Okay, so we can rewrite each expression in the form of 6 to the x, and see if the exponent expression is equal to t squared minus 2t. So we're going to rewrite this in the form of 6 to the x. So if we separate this, this now becomes, let's see here. Let's see if we can start to separate these parts here. This is going to be 6t squared times, let me see here. These are kind of tough here. 6t squared, 36t. Okay, okay. I can explain this a little better now. So this is 6t squared, 6 to the t squared over 36 to the t. That's just equal to 6 to the t squared over 6 squared t. Okay, now we can, and we're just looking at this first one here. Now we can simplify this. And this is 6 to the t squared over 6 to the 2t, because we're doing 2 times t. So that's different than t squared. Just be mindful of that. We're going to do over the line, change the sign. And this is 6 to the t squared minus 2t. So this first one is equivalent. We'll look at the next one here. 6t squared times 36t. So we can write this as 6t squared times 6 squared to the power of t. And here we'll put this as number 1. This is number 2. So this is going to be 6 to the t squared times 6 to the 2t. And we're going to add those. So that's 6 to the t squared plus 2t. So that's not equivalent to the minus. And for the last one, this is going to be 36t squared over 6t. That's equal to 6 squared to the power of t squared over 6t. Now we're going to expand the top. This is going to be 6 to the 2t squared over 6t. use the quotient rule. We'll just bring it to the top like we did with the other ones there. And this is 6 to the 2t squared minus t. That's pretty close, but it's still not equivalent to our original one. Okay. All right. So now we're going to go to some that, in my opinion, are a little bit easier. So if this part made sense to you, that's awesome. So these ones are a little bit less challenging, but they still have some rigor to them. And our goal for these, again, it's a similar goal. We want to have the same exponential base for these. Um, but we ultimately want to find a solution for x. So these are written as equations instead of just expressions. So 27, we can rewrite 27 as a power with a base of 3, and that's 3 to the power of 3. So we can now rewrite this as 3 cubed to the power of 9x plus 4 times 3 to the power of x minus 8 equals 3 to the power of x plus 9. So now this is 3 to the 27x plus 12 times 3 to the x minus 8 equals 3 to the x plus 9. Now, the product rule says that we add these. Um, and so if we add these, that's really just like putting a plus between those exponents. So because all of these have the same uh, base now, we can just get rid of the base. So you can get rid of the base and just put a plus there, or we can write one more step. So we can write 3 to the 27 plus x is 28x. 12 plus negative 8 is positive 4. And that equals 3 to the x plus 9. And then we just drop these and we can solve for what x is. And we're going to minus x minus x. Minus 4, both sides. Divide by 27. And we get x is 5 over 27. Kind of a strange answer, but that's our answer for that one. Let's do one more of these. I think these aren't as complex as the first ones. This one has a fraction in it, so we'll try this one with the fractions next. Okay. All right. So 125 is, we could probably write this all in terms of fives. But 25, let me see here. I think maybe we might have to do that because we can't say 25 squared equals 125. Let's reduce this 25 and then we'll also reduce the 125. So this would be 1 to the 5 squared, all to the, or excuse me, 1 over 5 squared, all to the power of 2x plus 3 is equal to 125 is 5 to the power of 3. And then that's 9x plus 8. Okay, so now we're going to distribute these. I'm going to write this as a negative. So I'm going to write this as 5 to the negative 2 to the 2x plus 3 is equal to 5 cubed. Actually, we'll just multiply that now. That's 27x plus 24. And now this is 5 to the negative 4x minus 6 is equal to 5 to the 27x plus 24. Drop those fives, and now we just have a standard multi-step algebra equation solving this for x. So if we plus 4x over here, gives us negative 6 is 31x plus 24. And this is simple algebra stuff here. We get negative 30 is 31x. Divide by 31 on both sides. And we get x is negative 30 over 31. So we might get some strange answers for these. So if you get an answer that seems like maybe it's close to a whole number, and you think maybe you got the wrong answer, you probably got the right answer for these. So we get some unique answers for these ones. Okay, so this one was, make sure we're on the right track here. This we did these. Just trying to find our next problem. Actually, we did not do any of these with the radicals yet. Let's try one more with these radicals. And this might be a review from quiz 1, but it's actually on quiz 2 for the practice. So, oh, okay. So yeah, we have to find the same base for these. So far, if we rewrite it like a fractional exponent, that's 250 to the 1/3. And that's 2 to the 1/3. But if we do powers of 2, 2 to the power of 8 is 256. So we might have to do some reducing and expanding for this one. So this is kind of unique. So I think instead of doing it like this, what we'll do is we'll rewrite it like the cubed root of 250 over 2, because it's the same root for both of them, the same index for both the numerator and the denominator. So now we have the cube root of 125. And so the cube root of 125, that's a lot easier to solve. That's 125 to the 1/3. And we can type that in our calculator. Just make sure you put parentheses around it because you're going to use the divided by symbol for the fraction. Um, so make sure you do the parentheses, and that just equals 5. Okay, so that was those. I'm just double checking here to make sure that we've gone over everything for quiz 2. So we did the expressions, the challenge expressions, the equations. Let's try just one more equation. And if you feel like you're ready for this, then that's great. You can start the assignment, but let's just try one more equation here. So this next equation says solve this for x, and it gives us an equal sign. So that's how we know we can actually get an answer for what x is. We'll write the 125 in terms of 5 as our base, and everything else is in 5. So that's I think manageable to work with. So 5 to the power of 3 is 125. So now that's 5 cubed, or 5 to the power of 3 to the 3x minus 1 on the denominator. And then this all equals 5 to the power of negative 5x plus 2. This is 5 to the 6x plus 5 over 5 to the 9x minus 3. And that equals 5 to the negative 5x plus 2. We didn't do anything to the right side there. Now we do over the line, change the sign. I'm going to bring everything to the top again. So we're going to bring that to the top. And that's going to make everything over 1. So I'm going to actually just get rid of the fraction because over 1 just means the number itself on the numerator. So this is 5 to the 6x plus 5 minus 9x minus 3. Now, for this next part, we've got to we've got to make sure that our minus is in the proper place. So when we minus, this ends up being like that. So we've got to have those parentheses there because the minus goes to the 9x and to the negative 3. If you forget that part, you won't get the right answer. So this is 5 to the negative 5x plus 2. Okay, so now we have 6x. Let me just rewrite all of this. 6x plus 5 minus 9x plus 3. And that's all equal to 5 to the negative 5x plus 2. So now we have 5 to the negative 3x plus 8. And that's equal to 5 to the negative 5x plus 2. Okay, then we just drop the 5s on the bases. And we solve for x. So negative 3x plus 8 is equal to negative 5x plus 2. 5x to both sides gives us 2x plus 8 is equal to 2. Subtract 8 on both sides. 2x is equal to negative 6. We'll divide by 2 on both sides. And then we get x is equal to negative 3. So that one we get a good whole number for that last problem there. Okay, so that is everything for quiz number 2 on rational exponents and radicals. Again, the key takeaway here is to try to match the bases. Try to rewrite these numbers as a similar base. That way you can apply the properties of exponents.